All right, well, how do, guys? So right now we are going to endeavor to learn clients and servers, and I'm sure you're anxious about that. So let's get started right away. So the foundation of modern networking. This is the centralized process and IT framework, and we have been calling it the client-server model. I don't see that that's going to change anytime soon because it is apropos. For over 50 years, servers have been the machines and mechanisms to process end-user requests and develop specific digital resources. So these requests include anything from a Google search on a smartphone to a remote employee accessing confidential company information. Now, in both contexts, a user device triggers a request to another machine, like a network server, which receives, filters, processes, redirects, or any combination of these actions before returning an adequate response. So you see, the client-server model is a network architecture, and it describes how servers share resources and interact with network devices. For modern enterprises, as well as data centers, many servers facilitate processes like email and printing, internet connections, application hosting, all these kinds of things. So in other words, everything that you'll be working on from here on out. All right, so the client-server model describes how network devices like workstations and laptops and IoT devices, known as clients, make requests to network machines or software capable of completing the request, known as servers. Just to be clear, we're on the same page, right? Now, although servers historically have been physical appliances like rack servers, data center trends show administration increasingly deploying virtual servers for a range of workloads. Now, client-server framework, in fact, all client-server frameworks, contain three primary ingredients: clients, servers, and the networking devices to connect the two segments. For a few examples of clients, there would be workstations, desktops, laptops, tablets, smartphones, IoT devices. You know the drill. A few examples of a server would be a database server, a DNS, web application server, file servers, and proxy servers, and we would also include virtual machines. Now, how about a few examples of networking devices? Well, these would be your hubs and bridges, switches, routers, gateways, and modems. Now, enterprises once relied on workstations that shared a single operating system. But today's IT environment strives for interoperability between systems, devices, applications, and products. Then, because network clients are increasingly heterogeneous with devices as well as OS types, administrators have the added responsibility of ensuring compatibility. So isn't it great to have purpose? Anyway, let's talk about servers. The hyper-focused machines delivering IT resources to clients are the physical, virtual, and cloud-based servers housed in modern data centers. Servers are the central authority for several essential digital processes that enterprise organizations rely on. The framework calls for physical or wireless networking devices like hubs, switches, and routers to connect servers, clients, and resources. Now, with a connection between clients and servers established, administrators can configure how client devices make requests and then designate servers to complete specific tasks. All right, so what you're looking at here is the process that an operational client-server architecture facilitates. So first, the client submits a request through a network-enabled device. And then the network server receives and processes the request. And once that's together, the server delivers a response to the client. Now, although it may seem simple, this client-server model is widely applicable and relevant to anyone seeking to understand content delivery networks, or CDNs, or the mechanics of edge networking. As server capabilities move closer to the network edge, the client-server process is physically closer to end users. All right. Let's talk about facilitating email. Of course, communication is essential to enterprise organizations. Snail mail can't really compare with the speed and reliability of electronic mail. No duh. But the hosting of email communications for an organization or network by a specific server has been the longtime industry choice to control particular email accounts and activity. Through a few different protocols like IMAP and POP3, SMTP, administrators can establish a system that facilitates, secures, and maintains email communications. So when using their email accounts, staff are the clients making requests to send emails, upload attachments, and store contacts to an email server. Now, when a web client wants to access a specific website, they'll enter the URL, and then the browser requests an IP address from the DNS or domain name system. So it's the DNS server that assigns the user an IP address for identification and delivery of results. By navigating to the website, a client triggered specific web content that the user can only access via an HTTP response provided by a web server. So in this case, the end user is the client presented with digital content. The DNS server and the web server both establish and facilitate the connection to a database hosting the web content. Of course, we'll have to go over some of the advantages and disadvantages of our client-server model. So, of course, the advantages would include central access and control of data, efficient, scalable, and organized systems, load balancing for optimal performance, redundancy as well as data recovery options, and interconnected network of devices. But of course, advantages come with some disadvantages, like less control of some network devices, upfront costs as well as implementation, technical expertise for ongoing maintenance, servers at risk of DOS attacks, and clients are attack vectors when breached. So these 4 types of client-server frameworks are pretty representative of how the client-server relationship evolved with networking advancements. There is a one-tier, all-in-one system. So all client-server configuration settings, user interface, business logic, and database logic sit on network devices in the base client-server architecture. Now, it's often limited to smaller networks, but one-tier frameworks include presentation, business, and data access layers on the same machine. Two-tier architectures add a server to the mix and separate the presentation layer to a user interface, where the client makes requests outside of its capabilities. So clients and servers take on more business and database logic at varying levels, providing administrators some control. To further protect and enrich the two-tier architecture, this framework incorporates middleware between the client tier, the presentation layer, and the server tier, which is the database layer. Now, this application layer provides a third tier, enabling more complex management of business logic. Examples of middleware like web application servers offer load balancing, increased storage, and security. Now, working off of the 3-tier architecture, N-tier describes a further use of middleware to segment network traffic and functions. And although this comes with greater complexity, modern enterprise organizations require multi-tier architecture's flexibility, scalability, and security. All right, so hey, guess what? That's all we got for you right now, because that's a lot. Go back and have a look at clients and servers if you need to review anything, because this is on a need-to-know basis. You need to know it. See you next time.